Hello everyone, I wanted to talk about this paper called Associations Between Alcohol Consumption and Gray and White Matter Volumes in the UK Biobank. This was a paper published in Nature Communications just recently, March 4th of 2022. Let's read the abstract together. It says heavy alcohol consumption has been associated with brain atrophy, neuronal loss, poorer white matter fiber integrity. So if you remember, white matter is the part of your brain that has mostly nerve fibers that connect the parts, and gray matter has a lot of the cell bodies. Poor white matter integrity. However, there is conflicting evidence on whether light to moderate alcohol consumption shows similar negative associations with brain structure. So we know if you drink a lot of alcohol, that's bad for your brain. What they wanted to know is a little bit of alcohol bad for your brain? Because there have been, you guys have probably heard the studies like a glass of wine a night is good for your health. Alcohol in moderation is fine. As long as you don't abuse it, a glass of wine a day is actually a good for your heart. And there are papers that say that a glass of wine a day is good for your heart. It is. However, it may be bad for your brain, and that's what they're figuring out. And it may be bad for a bunch of other things. The part of the wine that's good for your heart is resveratrol, and that's just in grapes. So you can get the benefit by eating grapes as well. Okay, anyways, back to this paper. To address this, we examined the associations between alcohol intake and brain structure using multimodal imaging data from 36,678 generally healthy middle-aged and older adults in the UK Biobank, controlling for numerous potential confounds. So they have a large data set of close to 40,000 people. They've imaged them. These are middle-aged and older adults, which you would, that's who drinks alcohol. You're not going to look at little kids and seeing if the alcohol affects them. Controlling for numerous potential confounds. So they look for, the other medical conditions, age, because brain matter atrophies with age anyway. So they're, socioeconomic class, whatever. They've looked at a bunch of potential confounds, which we'll discover while reading this paper. Consistent with prior literature, we find negative associations between alcohol intake and brain macrostructure and microstructure. Specifically, alcohol intake is negatively associated with global brain volume measures. Negative means it's opposite. So more alcohol intake, smaller brain. Regional brain gray matter volumes and white matter microstructure. So it's alcohol intake is bad for all of that. Here we show that negative associations between alcohol intake and brain macrostructure and microstructure are already apparent in individuals consuming an average of only 1 to 2 daily alcohol units and become stronger as alcohol intake increases. So they find that even 1 drink a day is bad for your brain. And it just gets worse with more intake. Okay, introduction. They're talking about how alcohol is bad. We know that. Has all kinds of problems. All right. This current study examines the association between alcohol intake and measures of gray matter structure and white matter microstructure in a large population sample. We perform a pre-registered analysis of multimodal imaging data from the UK Biobank, which control for numerous potential confounds. The prospective cohort representative of the UK population aged 40 to 69 is the largest available collection of high-quality brain MRI scans, alcohol-related behavioral phenotypes, and measurements of the socioeconomic environment. Okay. All right. So our sample size gives a statistical power of 90% to detect effects as small as really, really small. So with such a big volume, they can measure small differences. So what we want to know is how big are these differences? Like, is it a little bit of brain matter loss or is it a lot of brain matter loss? And then, given findings, we hypothesize a negative relations between alcohol intake and global gray matter and white matter volumes in people who consume large amounts of alcohol. Okay, so large amounts, they consider 18 drinks a week for women and 24 drinks a week for men. So that's a lot. A large general population sample provides sufficient sensitivity to qualitatively and quantitatively assess how associations vary across the drinking spectrum and test at which thresholds associations emerge. All right, so let's look at this. Okay, this is the first time I'm looking through this paper too, so we're going to look at it together. All right, empirical distribution of variables. So 20,000 women, 18,000 men. Of these, they had 2,000 women that don't drink at all and about 1,000 men that don't drink at all. If you look at the age distribution, it's mostly it's from 40 to 79, looks like, and most of the median is 63. Okay, and the mean is 63 or 64. All right, daily alcohol unit. So most people are drinking 0, and then it kind of tails down with like 2 to 4. So there's not too many people that are drinking more than 4 drinks a day. Then total gray matter volume. So it's like average here and average here. So men's brains are bigger because bodies are bigger. Total white matter volume. Okay, head size. All right. Okay, so let's look at this. Scatter plots of whole brain standardized gray matter volume, all normalized for head size against the individual's age. So yeah, so as you see, gray matter volume decreases with age, and this is normal. Our brains all atrophy as we age. Unfortunately, like very few things get better health-wise as we age. And then white matter volume decreases, so that's not surprising. And then they measured it with the darker purple dots are in this plot are more alcohol consumption, and the redder dots are more alcohol consumption in these plots. Okay, but hopefully they have a better, easier to look at picture than this. All right, so this is scatter plots, all normalized against the individual's daily alcohol consumption. Oh, okay, all right, here we go. So this is normalized against standard volume. So I don't know what the scale is. Okay. So they're not giving you absolute volume numbers. So you see that the volume scatter is high. So you have people all the way up here and people all the way down here. So looks like based on the distribution of this, the change is fairly subtle. It's not huge. So if it was really tight and then the thing was bigger than the natural variation, that would be more significant. But you do notice that there is a drop-off in brain volume as your drinking increases. All right. And if you look at it, it's pretty subtle between 0 and 1. That doesn't look like too much of a difference. At 2, you definitely see a difference. But at 1, it's not a huge difference. See, so this is the way they did it. They went from, they grouped 0 and 1 together and 1 and 2 together. I'm not sure I agree with the way that they did that. Would have been nice if they just did 0, 1, 2, 3. And I don't know why they did it that way. Okay, so 1 to 2 would age you about your brain volume would be equivalent to if you were half a year older. I mean 0 to 1. And then 1 to 2, it's like 2 years older. So you're like your brain volume is 2 years older than you would be. So it's like, you know, it's significant. And this is gray and white matter. Okay, so the other one is just gray matter. Okay, so after controlling for this, that you see, all right, so here we go. All right, so here's 0, 0 to 1, 1 to 2, 2 to 3. Okay, yeah, so you see at 0 to 1, there isn't a change between 0 and 0 to 1. When you do 1 to 2, so I don't know why they did it that way. I'd really like to know if it was we just made 1, 2, 3, 4, 5. Because based on that graph I saw, it looks like one drink didn't make that much of a difference. 2 drinks definitely makes a difference. And then, it just definitely gets worse. Okay, let's go to their conclusions. This is all a bunch of neuroanatomy stuff that we're probably not super interested in. Okay, we report a multimodal brain imaging study of 40,000 middle-aged and older adults of European descent. So this is the caveat. Maybe this only holds true for European descent Caucasian people. Maybe it doesn't hold true for other ethnicities. Although I don't see why it wouldn't also hold true. But that's a caveat. Notably, the negative associations observed are detectable in individuals who consume between 1 and 2 alcohol units. So I don't know why they just did that. They should have just done 1 and then 2 and then 3. Okay, maybe their survey data just had that kind of data. People didn't say I have 1 drink a day. They just said I either do 0. Okay. Now looking at this, I bet that's why they did it this way. I'm almost positive. When they gave the survey to the people, when they were collecting this data, they asked the people, do you drink none? Do you drink 1 to 2 a day? Excuse me. I always have to sneeze twice. I don't know why. Okay, so I'm sure that's why they did it this way. They asked the people, because this is how surveys are generally. They ask people, do you do no alcohol? 1 to 2? 0 to 1, 1 to 2, 2 to 3, 3 to 4, and above 4 or something like that. That's why they did it this way. Okay, so that makes sense. That makes sense. I'm like 99% sure that's why they did it that way. Okay, all right. So, anyways, this is a very interesting paper. I think it's for sure you can say with a data set this large, there is changes in brain volume, and loss of brain volume is usually not a good thing. And that's associated to be about 2 years of extra brain aging with 1 to 2 drinks a day. So with 0 to 1, it's less. It's not significant. So somewhere around 1, I think, is the cutoff. It seems like based on this data. So 1 drink a day is probably too much. Less than 1 drink a day, maybe 1 drink every other day, you're probably okay from a brain sample. At least the atrophy is so small that they can't pick it up in this paper. All right, so I hope that's helpful. And it's a very interesting paper. I will link this paper in the description. And thanks for watching, everyone.